Okay, so let's talk about strings in Java. Now, I've been using strings throughout this example, so you've seen me using them in various ways, but let's pick a few select examples from the code and point out a few things there. So, put it into a block just like this, and here's one that we used. We put together a string as a return from a toString method. So we have a constant here, and we concatenate that with an integer, and then we concatenate that with another string constant, and concatenate that with a string variable, and then another string constant. So the plus sign concatenates strings, obviously, or apparently. Another example. Same thing here, we concatenate different strings. We are concatenating this string constant, calling with an integer I, and we are concatenating that with the colon and something else which we get as a return value from calling the callNum method. So this callNum method returns a string, and then we concatenate that. So nothing new there, but we get to see how we do a printout of things as well. Another example where we concatenate, we have a string and we concatenate something else, a comma sign at the end of it. So nothing strange or untoward here, we are just basically putting strings together. We had another example in the callNum method, like so, where we are, let's say in this case we're taking a string in and we want to return a string. What we do is, in terms of string concatenation, is down here we are putting things together like there, and once we are done we are doing something else, we are returning the string or something else there. So just a few examples from the source code to show that we can use strings in various ways. Now, the problem is with strings in Java is that it's something between a built-in data type. As you see, I can have a literal value, a string constant in the code like that, just as I could have a number like an integer or whatever. It's also a class. So when I create a new string, it is done with the method as if it was a class. So I have my string equals, and I can do in two ways. I can do a new, like this, which of course is a bit redundant, since I can also just give the string literal there. So it works like a class, it works like a built-in data type, but there are also things that makes it not work like a built-in data type, and the most important thing of those is that strings are in Java immutable. And that's something which is important to remember, because what that means is that if I have a string and it's got a value, I can't change that value. I can't. So when I'm doing these concatenations up here, I'm putting together one part of a string with another string, or something that is converted to a string. This is actually a new string, and then I put together this with another string literal, which means that I have a new string again, and a fourth string, and a fifth string. So this one line generates 5 or possibly, well, 4 or 5 new strings before it's done. And that's the one I get returned. And any one of them I can't change them. So down here, this my string that I created here, I can't change the value of this one. It will always be hello, question mark. If I want to change the value, I get a new string back. And that's sort of important to remember, which means that it's going to be, I can't, for example, pass a string as an attribute to a class and change that attribute and hope that the string has changed when I'm done, I have to return the string in that case in order to actually say that this is the new string, which is sort of nice anyway if I want to have immutable functions. So concatenation renders a new string, or yields a new string. And what does this mean in practice? This means that if I just do it once ever so often, it's okay to use the plus operator and concatenate strings. But if I want to do something, if I want to build up a string continuously, let's say I want to do some sort of output. Take the Fizzbuzz example, for example. If I want to get an output which is built up by counting all the numbers from 0 and onwards and putting fizz where it's supposed to be fizz and buzz where it's supposed to be buzz, from say 0 to 10,000, I don't want to do that with a plus concatenation, because then I'm going to create 10,000 new strings. So what I need to do instead is to use a string builder, which allows me to add to a string until I'm done. Let's give an example of that. Like this, and then put the class in here. I can import it. It's not really necessary because it's in the Java lang library, which is sort of included by default, but it's always nice to be explicit and make it clear. I've got my class, and let's put things into a main function here. And what I want to test here, I want to generate a string builder. And put something into it. Like so. And then I want to to add something to this string. So this will work sort of like a string. I can now do things that I want to do. I can append to it, and I can insert things, and then when I'm done, I can convert it to a regular string, which I then can pass on. So this is the way I would use if I want to build up a string in a series of events, just to make sure that I don't have 10,000 new strings created, which I immediately throw away because I concatenate it with something else. So let's append something, and let's insert something. And with insert, of course, I have to give where I want to insert it. I pre-counted it so that 8 steps into my string is going to be somewhere around this space in the middle here. So that should be more or less right. And then let's create a string out of this. The toString method is always available for all Java objects. So all Java objects or all Java classes actually hidden from plain sight inherits from a class which is called java-lang.object, and this class contains a method called toString. Normally that, just as we've seen in some of the examples I've been running, we get some sort of default, this is the type of this class, and a pointer. And we can override it with something which is more useful for us, like we did, for example, in the callout class, where we gave it a more meaningful output. But it also means that most Java classes have some way of, if I have an object of the class and I want to have a string representation of it, there is a toString method which I can call. And let's print out this string that I just created now. Like so. Let's run it. And I get the string initial string, and I've inserted something in the middle, and I've appended something in the end. And that's what I wanted. So this is if I want to build, if I have the one or few cases where I know that I'm going to call this method, like the ones where I do toString up here and so on, then sure I can use the plus to concatenate things and be a bit lazy about it. But the moment I am building a string out of many small parts and putting it together like that, that's when I use the string builder instead. And as you see, it's fairly straightforward to use and it doesn't add that much code complexity, so it's rather nice to use. Next step is to convert strings. So I've already talked about the toString method, which is built into all classes, and I can use that to get a nice string representation. If I want to use, if I have a number and I want to generate a string out of it, or rather, then I will be using the toString method. If I have a string and I want to convert it to a number, I'm going to use something else. So for every built-in data type, like an integer, like a boolean and whatever, there is also a class representation in Java that gives me a few methods. Normally static methods, I don't have to create instances of the class, but I can do that in certain cases. That will allow me to do conversions from strings, among other things, from strings to that built-in data type. Let's put in something. Put this into a class. So, and within this class, let's have our regular static main method and put stuff in there. I'm being lazy and copy pasting this one. Now, what do I want to do? Let's have a string from which is actually an integer. Let's have another string which is actually a float. And let's do some conversions of this. I want to have an int, which is really an integer, and then I'll use the built-in class representation for an integer. And there is a static method called parseInt. This will convert the string si into an integer, which knows how to convert itself into an int. Or maybe even the parseInt returns an int. Yes, the parseInt returns an int, which is even nicer. And I can also do the same. I can parse this integer as if it was a float. Like so. And I can, of course, convert the float string I had into a float as well. And then let's print what we've got. And just to make things more exciting, let's add a number to it as well to show things. So just printing this integer, which would of course work as expected, but let's add a number just to show that we actually have an integer or a float, because now the plus sign doesn't work as a string concatenation. Now it works like a normal addition again. No, what happened? Oh. Simple misspelling. So 1, 2, 3, 4 plus 10 is 1, 2, 4, 4, which is an integer. And if it was a float, I get 1244.0. And 47.11 plus 10 is 57.11. So that's how I do conversion from a string into an integer or a float or whatever I want to convert to. Of course, I would have preferred to have just a method called parse, because then I could use some polymorphism and stuff, but this is Java, so I need to keep track of, I actually want to convert it into an int, so I use parse int, or I use parse float, and so on. One of those things in Java, you just have to live with it. And as to repeat as well, there is the toString method, which is available on all objects. Not the built-in data types obviously, but all other objects have a toString method that will convert to a string in some form or other. And you, if you write your own classes, you can define yourself what you want in there, and the built-in classes usually have some meaningful thing to put in there. And that is what I wanted to say about strings.